In this video, we'll be talking about the layout for Mach3Turn, and we'll be going through each individual window available on the software as well. Upon startup, this will be the main screen we'll be seeing. You may have noticed that the reset is flashing as normal upon startup. To deactivate it, just go ahead and click, and the red lights will stop flashing. When we need to set up our offsets for our tools and our workpiece, we want to go ahead and go to the manual window here. To access it, go ahead and click on it. Inside the window, we can see that everything has its designated area. The first thing we want to do is set the home position for the lathe. Every time the machine is turned off and turned back on, or if the software was closed and reopened, the software will lose its home position in the lathe. So the best way to set the home position is by clicking Set Home X and Set Home Z. This will move the axes in their respective direction towards their home. Once they are home, then they know where home is, and when you click Home All, that's where they will go when finding their home position. As for the axis, we are using a lathe, so there's only two axes, the X and Z. Important thing to note is that if this is our aluminum rod and it's being held in place by the chuck on this end, that means our Z positive will be going in this direction, and our positive X will be going in this direction for our lathe setup. In order to move the x-axis, we want to go ahead and use the up arrow key for positive. In the negative direction, we want to use the down arrow key. For the z, if we want to go in positive, we want to use the right arrow. For negative, we want to use the left arrow. For the tool DRO, this is for referencing our turret with our different tools. It will be measured in degrees, and to control that, we will be using W and S keys. The W key will rotate the turret around, allowing us to change between tools. And the S key will allow us to lock the tool into place. We will know when the tool is locked in place when the motor starts to stall. Please note that the number will keep continuing even if the motor has stalled. So if you do stall the motor and you go too far, you can adjust the number in the window by clicking it and typing in the value you want. Say that we were rotating to tool 3, which is 90 degrees. If we accidentally went past 90 degrees when installing the motor, we can just simply, again, click in the window, type 90 degrees, and hit enter. And now it's set for 90 degrees. Over here is where we control our jog speed. Again, if we want to change the speed, we can go ahead and highlight the box and enter the value we want. Say like we want to go from 1% of our speed rate to 100%. You can just click it, type in 100 and hit enter. It also displays the number of tool that we're using. Over here shows the control for our spindle. In order to control the spindle, we can go ahead and highlight this box and type in like 700 RPM, and it will propagate up to here when we turn on the spindle motor. One thing to note that these coordinates have two systems, a program coordinates and a machine coordinates. Program coordinates is what we'll be using for our tool offset and our workpiece offset. Machine coordinates just basically tell where the machine is in space within its domain. And again, these work with soft limits, basically telling the machine you cannot go past or this point, and it will stop you before you go any further. If the hotkeys are not working with your axis, there are hard buttons that are available on the software. To access those, just go ahead and click the tab button, and it will pop up this window on the side, and right below at the bottom will show the hard buttons to control the axes. To get rid of the window, you just go ahead and hit the tap button again, and the window will disappear. Below here in this bar, this is the manual data input, or MDI, where you can manually input G code. All you have to do is just click in the box until your cursor shows up and type in a command, say like M3, which will start the motor. As you can see, when I type that in, this yellow bar came alight, and that should indicate to the software to start up the motor. Below here are simple buttons that that turn on the jog, turn on the spindle, or stop everything in its tracks. And this window here is a window that shows the toolpath generation from your G code. But as you can notice, we are not able to upload our G code in here because this is the manual and it's only meant to find the offsets for your tools and your workpiece. When you're done in here, you can go ahead and click on quit this mode. Once we have determined our offsets for our tools and workpiece, which will be explained in a later video, we can go ahead and go into the auto window. And you may notice that the layout is pretty much similar to what we have for the manual. The only difference is we are now able to load our G code. So to load our G code, we can go ahead and click load, locate where your file is being held, and open it up into the software. And in this window, it will generate the toolpath for based on your G code. And once everything is set, you can go ahead and click cycle, and it'll open up different options on how you want to start your G code. Generally, once everything's ready, you can just go ahead and click cycle start, and it will run the G code operation. And that's the only button you really need to worry about. There's also the stop function. So if there's any errors or issues that are about to arise, you can quickly go ahead and click on this to terminate the operation. You also have the ability to edit your code if you do spot an error. So if you do need to edit, just go ahead and click edit. It'll pop your G code into a separate window of like Notepad and allow you to make edits to your G code. Once you're done with that, you can go ahead and click the X. It'll automatically save and reload into the software, ready to be run. Once you're done running your operation, go ahead and click this arrow key to exit out of that mode. And with that, manual and auto is the main screens we'll be using, but the software also has other screens that we want to consider as well. So once we're done with operation, we can go ahead and go quit mode. And then we can go ahead and enter tool table. In here is where it houses all our tool information, like for tool 1, which is our reference. Then the offsets would be 0 for all. And we must also note that the tools that we're using will be paired with odd number entries. So our right-hand cutter tool will be tool 1, and our left-hand cutter tool will be tool 3 for the system. And we'll go into greater detail of tool offsets in later videos. But again, this is where it houses all our most of our tool information. But if we do come across an error and we don't know why, the best place to go is the tool diagnostics. So if we go ahead and quit the mode here, and then we go to diagnostics, it provides a screen that shows different input signals, like these LEDs up here refer to the limit switches. If a limit switch was triggered, then it will illuminate which of the limits were triggered. Same thing with the emergency, only difference is that it will be flashing. Also, an important thing to note before we run any operations, we want to make sure that auto limit override is engaged. That way, we do hit a limit switch, we can easily undo the reset button here and move it. If this was not engaged during the operation, then we will not be able to disengage the reset. That means then we'll have to go to the setting, discontinue that input signal, move the axis off the limit switch, and then re-engage that signal, which will take time. This window also provides an MDI line as well, but this page will mostly be used for diagnostics and to see if there's any other troubleshooting that needs to happen. And with that, that's the Mach 3 turn layout, and thank you for watching.